A quick instructional video for anybody interested in putting together their own microwave imager. Um, I've been using mine for the last few weeks, and the code that I'm going to give away should work with any Mac or PC or even Linux. You're just going to have to go in to this portion of the script if you're not familiar with Python. Um, that's what you're going to have to do first. I only had about an hour of Python training out of like a 12-hour course. And so most of what I did was I had a lot of help from ChatGPT. So if I could do it with an hour of Python, then anybody could do this. It's just a matter of getting the hardware. And that shouldn't be too difficult. If you go on Let Go, which is what I did, you can first of all just type in dish tailgater. And what you want to do is find the version that looks like an octagon. This one's only $25. It's about what I paid for mine. It should look like a little octagon. And if it does have this shape, that means it was manufactured between 2011 and 2014, maybe 15. I'm not sure. I haven't seen any 2015 versions, but this is what you need. And what you're going to do is there's some little screws right here. You're going to take those right out, and it will reveal the brains of the LNB and the brain for the motor steppers. So what you want to do first when you get it, because they are used devices and you can't trust things as they get shipped. Things get knocked over, and this does actually have a tilt sensor that is necessary. That's what this is right here, to calculate the position of the pixels as they're being created visually out of the RF energy readings. So you have to make sure that you check everything. And the way you're going to do that is before you download Python and PyCharm, you're going to go, first of all, interface with the device. So you're going to write CoolTerm in the search. I misspelled it. And then you're going to go to the very first Roger Myers freeware, and you're going to download CoolTerm for whatever operating system you have here. And any of them should work. You could actually also run this off of a Raspberry Pi. So once you download that, you open up CoolTerm and you go into the connection. Same thing, it'll be the same on Windows. You go to connection options, and then you're going to find, these are all the ports you have available. You find out which one belongs to the dish. On a Mac, it'll say USB modem. I don't know why it recognizes it as a USB modem. And then you just choose that. And you're going to take the, if you go over here, you can see the actual, what you're going to type in. So you could type either this in right here, or you could have what I have on the code right here for the screen grab. So, and you have to make sure before you punch it in, Python is, you have to have everything indented for every command. So you have to make sure this is the only thing that you're going to change, unless you decide to go in and make your own changes afterwards. You delete this, and then you're going to make sure that you put the parentheses first. If you hit either the double parentheses or the single one, it will let you paste in there. But I'm just going to keep mine like this. This is all you're going to change. And then once you download Python, you have to make sure that you have specific, is where it gets a little bit complicated. So you go down here to the lower right hand corner, you're going to click on that and go into interpreter settings. And in the interpreter settings, you're going to want to make sure that you have specific, these specific, where are they? Modules, I think they're called. I'm not sure what it is. It's they're like they're pre-written lines of code that will help you take the data and then turn it into a PNG image. So here's the original. This is what you're going to want right here. You're going to go in and download all of these guys right here. So NumPy, PySerial, regex, and matplot library. All of these are used to take the RF radiation energy and convert it into a PNG image. So you go in and how do you do that? Let me see here. Project Python, I think you hit plus. Yeah, you hit plus and you hit. You can do something called, you go into the terminal right here, right over here, whoops. And there's a thing called pip. You could do it through here too, but you're gonna go into the terminal and then pip install, whoops, I don't know what just fell. You're gonna install all the modules in there that I have listed right here. So NumPy, PySerial, regex, and matplotlib. You need those installed, and then you can check if they're running in the interpreter settings. You want to make sure that they all end up in here. So here's all of them right here. NumPy, I have a lot of extra stuff in there. Not sure how they got in there, but as long as those are in there, if you're not sure about what I just said, just go online, write Python pip and install, and it'll walk you through how to install these things so it'll work. So once that's installed, I'm using PyCharm, so that's what you're going to need to run Python. And you go to Python, download. That's JetBrains. Where's? I think it was this one. You're going to go down to the community version right here. So you just download the community version. This is a professional version. I don't know what the difference is, but you could do everything from the free community version right there. So, but the first thing you're going to do if you do get this dish is go into your, you get it, you connect USB-A to USB-A. If you get a 2011, it'll be USB mini to USB-A. You find out where it is, and then you connect to it. So I'm already connected, so I'll clear everything, connect, and the first thing that you're going to do to see if you're connected is hit help. You hit help. This is a list of all the commands that are pre-programmed into the dish, and you're going to test everything. The first thing you're going to want to check is if your elevation angle and AZ angle are options that are in there. If they're not in there, then you are going to have to alter the code, the Python code. But if these two are in there, AZ angle and L angle, what you're going to do is hit L angle. Let's say for me, this 2012 model is written in motor steps. There's 1,200 motor steps. So the 2014 version has azimuth elevations. So you have your this is your azimuth. For me, 400 is the 0 degree mark, and this doesn't tilt all the way up to 90 degrees. It goes about 70 degrees. So you're gonna hit either AZ angle. If you're lucky and you got a model that is in degrees, then you're gonna want to go and use somebody else's code, and you can find that in GitHub. So you're gonna go to GitHub, microwave imager. It's this guy right here. Save it for parts. He was the original person that I got the idea from, but his code didn't work with my version of the device. And I think that you're more likely to find these older versions that are not programmed in degrees and are in motor steps. But if you do get lucky and you get a 2014 version, then his code will work right out of the box. And so first thing you're going to do is check. So you send elevation angle 400 to see if it goes down. It's always off by like 1 motor step, but that's okay as long as it's pointed to the 0 degree angle, and L angle 1600 is my limit. And so that will move the dish 70 degrees tilting upwards. And once you do that and you see that it's working, you could also try the AZ angle. That's how the dish moves 0 to 360 degrees. You might want to reset all the way to 0 when you first get it, just to see if the motor is running correctly, like there's no problems with it. See if it got damaged while it was being shipped, which is why you're better off looking for a local person. See, I'm already seeing a problem here. L angle 1200. This motor, it won't stop itself. So if you go past the limits, it's not going to stop. It's going to keep trying to go until you send it a second command. So you need to be able to have CoolTerm to mess around with the all the serial commands in here. I don't recommend screwing with this or this. I don't recommend playing with the calibrate tilt sensor either. It might be the reason why mine is off by 1 motor step. It's very sensitive, and I do believe that tilt sensor is how the radiation readings are measured and then plotted correctly. So once you use this, you figure out what your port is, you go into PyCharm, and then you're gonna put the port that you're using in here, and then you go up right up here, hit make sure you're disconnected. You can't have 2 serial connections simultaneously. If you do, you'll get an error. So just in case that happens to you, that's what this looks like right here. It'll give you all of this. And just another heads up, if you are going to try to do this, you don't have to really understand all of what you're looking at. You can just literally copy all this. This is what I did. A lot of trial and error. You're going to copy it all, and then you're going to go to ChatGPT. I recommend forking out the $20 a month. It's totally worth learning AI right now. And then you're just going to feed it the result that you got if there is an error, and then it'll walk you through how you fix everything, or it'll rewrite the code for you. So once you have everything connected and you're the only one using, so I'm going to disconnect from CoolTerm. And then before I disconnect, I like to reset the dish to AZ angle 180, just so it's pointing forward, because it takes about 11 seconds for it to sweep from 270 degrees to 90 degrees. And the timing on this code is not the greatest. So sometimes it moves too fast, sometimes it moves too slow before it starts looking for the reading of the radiation in that quadrant of the room. So just reset it over here, and then once you reset, then disconnect. Once you're disconnected, now PyCharm could take over all the serial commands, and then you're going to hit play, or you're going to run the script to get a panoramic of the room. And this is what I'm talking about in case you're curious. I have find another panoramic. I have an old Osmo, but you can just use your iPhone and spin it around the room. So this is a 360 degree panoramic of all the radiation in the room. And all of this is noise. You probably want to start out by putting it in a room where there's not going to be much movement, or where things are going to be fixed, so you could get an idea of all the K-band radiation that is in there, or just the radiation in general. Because even though this is looking for KU band radiation, it will image any microwaves in the room, including your Wi-Fi router, your cell phone. I actually tested the code that I'm using right now with a cell phone. But back to this. So you hit, I'll stop it. So you hit, you execute or you run the script, and it's going to start prompting you for things. So this is the azimuth from 0 to 360. And in order to get that 180 degree panoramic, you just do 90 degrees for the first input, 270 degrees for the second input. So that's 180 steps from 90 to 270. And then you're going to do your starting elevation. The original user recommended that you don't do anything more than that. You don't do exactly 0 degrees. I haven't had any problems with that. He starts with 5 degrees and then he elevates from there. But I've been using 0 degrees. It's fine. There are, I think, versions of this dish that are the gears grind or something. So if you do have one of those versions, and you might want to just put like a 3 or 5 in here. But I usually do 0 for the horizon. And then if you want a full panoramic, and this does take a long time, then you're going to do, I haven't done the full 70, but so I'll do like, I think I did 68 yesterday, and it was enough to get a majority of the room. So I'm going to go ahead and do, just for demonstrative purposes, I'm only going to do 3 degrees. And then the resolution, I have not tried doing the high resolution. I don't recommend doing the high resolution. I think it might quadruple your time, not double it. It's sweeping back and forth, and it's not the fastest device in the world. So just hit 1, and then it'll automatically start. But it's already connected, so I'm gonna have to wait for it. I'm not recording this, but I'll just execute it. So also super important, when you download these off of my my Dropbox links that I'm going to leave next to this video, you're going to want to put the 2 Python scripts. This one is the one that we're running right now, and this is the one that's going to turn your image into a heat map. So you want them in the same folder, and I'll show you why. You don't need to have these both. I wasn't sure how PyCharm or Python worked initially. You don't need to have both of them here. But if you don't have them in here and you want to run PyCharm and you're not sure how to use anything, you literally just take them and then drag them in. So that's all you have to do, at least on a Mac. I don't know if it's, I think it's the same on Windows too. Don't know about Linux. Also, that original code is written for Linux. If you do go on GitHub and you get the original guy's version, he was using Linux. I forget which distribution it was, but he named 3 of them. So once you have those 2 Python scripts in the same folder and you're running everything, if you ever want to go back to that little screen that had all your options, it's right here where it says run. That's your terminal for the computer, just the entire computer, and this is what you're going to use for the program. So once you have all your parameters established, you hit return, and it'll start sending the instructions to the dish. That's all the grinding that you hear. And if you know just about where you're going to start, I recommend going into CoolTerm and actually just having it started there from the get-go, because the dish is very slow. And the problem is all these are the radio frequency reads. It's only taking the very first number, and it's using that as the radio frequency strength in that quadrant. You might want to, if you're picky, and I did try this on one iteration of this code, you can have it average out all of it. You could tell ChatGPT to rewrite the code, and I don't recommend doing this because you might go into a rabbit hole and spend a long time trying to get it to work again. So always copy and save the original. If you're going to screw with it, save the original and then try improving it after that. But make sure you have this iteration that works. But right now, this version just takes the very first number and it counts that as the value. And the reason why you need to have these both in the same folder is that as soon as you start getting the RF readings, what it's doing is it's taking all of these numbers right here. So each one of these numbers represents a little pixel that you could see updating right here. Those are values for the amount of radiation being um, uh, dispersed among 180 dots from on the x-axis, and then I think I did 3 degrees on the y-axis. And depending on what the power level is there, it will create a light or dark pixel to represent the amount of radiation in that specific quadrant of the room. It's not like a camera, so don't think that the LNB needs, or like the pointy part of the dish needs to be pointed at what you're trying to measure. It's using the tilt sensor in some way that I'm not sure of, some kind of trigonometry. That's the USB port right there that you want to plug into your computer. And you could check in where it is. So I'll grab my, actually I'm not going to bother grabbing my cell phone, but the way I've been testing this is I grab my cell phone and then, whoops, grab my cell phone, whoosh, grab my cell phone and I put it right up to the front of the dish, and it will actually create a darker red pixel to represent the more intense radiation in that given location. And so you could test and see if your LNB is actually working. You could actually test the LNB in CoolTerm too with the rfwatch 1 command. So the way the code's working is it sends a serial command to read. It's using this one right here, rfwatch 1. So you can take rfwatch 1 in CoolTerm, and then if you want to test and make sure that the dish's LNB is working correctly and it's measuring the radiation, you just write, when you're connected, I can't do that right now because this is using it. You just write rfwatch and then however many seconds that you want to measure the radiation. This is only measuring at 1 second. That's I think the original user said that that's the shortest amount of time, and it does take forever, so you want to use 1 second. If you wanted to try more than 1 second, I don't know what it'll do to your numbers, to be honest. You might want to just stick to 1 second, but either way, if you do 1 second, I think you get like, what is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 20 returns for 1 second of radiation watch, which is why I only pull the first one. But if you want to get picky, like I said, you could average it all out. It takes that and then it turns it into the pixel. So that's why you want to have everything in the same file. And I'm going to stop this. When it stops, when it's done and it goes through the entire cycle, it'll give you a little message saying scan complete. And then you're going to take those numbers and take these 2 files. So I'll stop this. We're not going to use these because these are not done. If you ever stop it and then you try using these values, you're not going to get a good heat map. I'm just going to throw these away. I already have so many trial and errors that I could just pull any of these examples. And so what you want to do is let me go to the test runs. So this was the result of another scan that I did, and I'm still not 100% with what this is. It might just be the way the code works. It defaults to 0, which ends up looking like this. If there's a lot of if the values go past a certain threshold, so I could improve the code, but for right now, this is good for anyone who wants to just start out and start measuring the radiation in the environment. So what you're going to want to do is, if you look at the second code, it's called dish image v1.2. You rename it if you want. Super simple. You're only going to change this, line 6 and line 7. And if you want to see different versions of the heat map, you're going to trade this with any one of these. Make sure that you don't hit the hash sign, or else it will comment everything out. So if you want to keep something from working on Python, you comment it out with a pound symbol. So we'll just do Inferno. You're going to go up to the settings, and this one is the scan settings. It goes where scan parameters equal, and this is the raw data, and that goes where data underscore file equals. So you're gonna on a Mac. I don't know how to do this on a PC, but on a Mac you hit Control Alt and then right click and copy the raw data as a path name. So you take that and then you're gonna put that right over here. Make sure you go over the green parentheses and Command paste, and it'll give you and the same thing for this guy. So Control Alt right click, copy scan settings as a path name, and then you're gonna go right in here. Make sure you highlight over the parentheses, and then Command V. And now the Python script knows to look in this folder for those for that data. And then if you want, you can take these to get different versions of the heat map. So this is what it produces when you run the first code. So the red dots that you saw earlier, and that's what it looks like. Already very telling. Like, I did this because I suspect that the house is under surveillance with RF reflectors that are described by Michael Osman in this video here called Nullcon GOA 2015. NSA 2015 is about the time that my targeting and my harassment, my electronic harassment started. So it's a pretty simple concept that I'm measuring it for, but you could use this for anything, for Wi-Fi routers, for to see satellites in the sky, to see the radiation coming from your Wi-Fi router. But it's a pretty simple concept. Mine looks incredibly messy because I get bombarded with radiation, and the radiation has a reciprocal receiver that's tuned to the same frequency that's being transmitted to what this version is using implants, but now we're at the point where you don't actually need any retroreflective anything. You can do this for biometrics. A lot of people don't know that. They think that you actually have to have a bug or a plant in your home for this to work. You don't need anything in there. It goes right through the walls, and you can see everything, hear everything, and most importantly, which is why I'm doing this, you can listen into a person's biometrics as outlined by Dr. Dina Katabi. Let me just show her because she's a really good example of what is technologically possible with these retroreflected systems. And this is why I'm sharing this too, because if you're a person who's being surveilled for no reason because you're not doing anything, you're not a criminal, yeah, it's not right. So, but this is what they see while they're shooting you with this radiation. And Dina Katabi is, she's an amazing inventor, professor out of MIT. She's taking the technology and she's using it for good applications. So in no way am I saying that she's like bad, and like this is what we're supposed to be doing with this kind of technology. This could like actually be put into hospitals, nursing homes. It's got a lot of benefits, but right now, unfortunately, it's being used to just spy on people and harass them. It's just like nuclear war. We could use nuclear energy to heat ourselves in the winter, or cool ourselves in the summer, or blow ourselves up, and we always choose to hurt each other before we use anything for good. That's just the way. It's just human beings are predatory by nature, unfortunately. So what you get with these technologies is
and what you
it lets you actually
the frame is actually what the radio signal is able to capture. So the radio signal can get these skeletons and it can get them through a wall. The image at the top,
I just wanted to show this
so
really
that
quick.
you guys understand what is going on in the scene. So let me play this for you. So you see, as he sits on the chair, you see the skeleton sitting on the chair. When he stands up, the skeleton stands up. When he moves with his right foot, the skeleton moves with the right foot. When he moves with the left
These are all technologies that are a complete violation of the Fourth Amendment, and they are being abused by, I think, a lot of non-state actors, people who work for the telecommunications industry, heavily deregulated industry. There's a lot of people who have access to all this, and they're just using it to maim and harass people. It's pretty disgusting. But anyways, back to the dish. You could use this for anything, though. If you're a person who's interested in radio astronomy or just SDR, just if you're just like an SDR hobbyist, this might be something that you'd be interested in. You could do a lot more than what she's showing right there, by the way. And I'm doing this too because these systems are not Dina Katabi's system, but the unfortunate reality with wireless radiation is that it causes cumulative damage. So you might not die of cancer, right away, but you may have your health affected by this. So that's why I'm sharing this, and that's why people need to know what's technologically possible and how you can maybe do something to make the surveiller's life a little bit more difficult. So anyways, once you copy and paste those two things and you choose which version of the heat map you want to see, you do the same thing. You just go up here and you hit play, and it will produce the heat map. So lightest areas are the hot spots, and darkest areas had the least amount of radiation. And what's really weird to me is how those spots appear. They may have actually been hot spots, because this is where it's kind of where my computer was on the Photoshop panoramic that I have. Like barely, actually, not really. So those could have just been zero values, and the way the code interpreted everything just turns it into black. On other iterations of the code, though, you can very clearly see the radiation coming off of the computer. But I was doing a more narrow area. I was only doing like 4 degrees. So instead of skipping 17 motor steps at a time, I was doing 1 motor step at a time. And it gives you a very high resolution visualization for that one portion of or quadrant of the room. But it's not going to actually fit with the panoramic. The only way to get a panoramic view is to have the correct motor steps and the correct sweep from left to right in 180 degrees. You could do 100 to 260 to speed things up, but I wanted to make sure that my panoramic photo matched with my panoramic radio scan. And so once you have all of that, you can I'm using mine and I'm sharing this for anybody who has been complaining about electronic harassment, because it is becoming more of a problem, especially as a lot of non-state state actors get access to these technologies. There's a lot of people who are being watched in very invasive ways. And so I highly recommend that not only do you get yourself a little microwave imager, but that you also get yourself a one of Michael Osmond's. You could get them from anywhere now. Hack RF with PortaPack. So there's a thing here. It's this thing right here. He has it right here. Mine's actually like the updated version. I have the 2024 Hack RF one with PortaPack and Mayhem built in. So it's basically an entire SDR like suite put together by a bunch of random. You could find a bunch of people who just build for it because it's open source. It's got like a screen and everything that you could do on SDR software you can do from this one thing. It's got a really nice range too. So I think up to 7.2 gigahertz. Oh, but where is it? So yeah, that's all you need to do. And super easy to find these things. They're all over. This is only $25. If you are lucky enough, you can get you can get a 2014 model, and I recommend using the original user's code if you do get a 2014 model. And he also, if you need any more details about which modules you need for PyCharm or for Python, he has all of that too. You're gonna download the zip file, and then it'll all be in there. But yeah, that's it. I just wanted to share that. I will have the links for this attached to this message in case anybody comes across and they just want to have it for themselves and try it out.